All right, so we just got done talking about blocking. And a matched pairs design is kind of, well, is a blocking technique. I always think of it as like a very extreme type of blocking. So a matched pairs design is a common type of randomized block design in which the subjects are put into blocks that contain two subjects that are most closely alike or related. So up here, we created blocks in this example that had 10 kids, 6 kids, and 4 kids. In a matched pairs design, you create blocks that just have two individuals. Every block is going to have two individuals. So you might say, man, your replication is really small. Yes, but what we're doing is we're putting two people that are most closely alike in the groups so that it really reduces all of the variables that you could possibly have, even the variables that we previously said we couldn't control, like these pre-cal kids. Well, we take maybe the top two kids. That's like the two kids with the highest grades, or maybe we could do it by gender. We somehow try to match the kids so the two kids in the block are the most alike, and then just compare the online to the class for that individual and for this group of kids and these two pairs of kids. That's how a match pairs design kind of works. Okay, so we break them into two pairs that are most closely alike. Then we randomly decide which of the two subjects receives each of the treatments and compare the response variable with each of the matched pairs. This extreme blocking, just like other forms of blocking, helps account for variation amongst the subjects. Activity, get your heart beating. So we're going to, hopefully we have time to do this in class. We're going to do this little activity about standing and sitting heart rates. And we will use a matched pairs design and try to illustrate the power or the importance of a matched pairs design. Okay? All right, so let's take a look at a couple of examples, and I think we're getting close to the end of this chapter. My beautiful hair. Researchers are studying a new shampoo formula to compare the condition of hair for people who use the new formula with the condition of hair people who use the current formula. So basically, we want to compare a new shampoo to an old shampoo to see which one makes your hair more silky smooth, I guess. 12 volunteers are available. So here's the volunteers, the gender, and their ages. If the researchers believe that the condition of hair changes with age but not gender, identify the blocks they should use for a matched pairs design. So if they think that your age of your hair has an influence on how the products are going to work, but that your gender doesn't matter, then they're just going to say, let's just forget about this. Let's not look at gender. We are going to pair people by their age if we're going to use a matched pairs design. So we got to put the two people that are most closely alike together. So that means these two would be together because they're the two oldest. So one block would have 5 and 6. And then the next two oldest would be 4 and 7 because they're the next two oldest. And then what do we got? 40s. We got a 47 and two 44. Oh, we got a 47 and a 46. So 3 and 12. We're just matching them as closely to the ages as you possibly can. Then that would be these two next, 8 and 9, because they're both 44. Then we got the young people, 10 and 11. And then 1 and 2, because they are the youngest. So we would randomly assign the new shampoo to one and the old shampoo to the other, and we would just say, let's see how their hair compares. Okay? If the researchers believe that the condition of hair changes with both age and gender, then how are we going to pair people together? So I'm not necessarily going to put the two people that are the oldest together, but rather the two people that have the same gender and are the oldest together. So instead of the two absolute oldest, I'll put the two girls that are oldest together. So this would be the female and old group. And then we got a guy. Here's the guy group that's a little bit older, the old guys. And then let's take a look at the 40-somethings. So here's the two females that are in their 40s, 8 and 10. And 44, and there's the two guys, 3 and 9. And then for the young people, we would go the two young guys, 21 and 1 and the 23-year-old, and then the two young girls, women, sorry. Where's the young female? 20 and oh, here. Did I screw that up? Let's go back here. 8. 8 was oh, I should have been this. The 40-something female is matched with the 40-something female. That should have been 8 and 12. Sorry. So now we can see how each of these react to the different shampoos. These are two girls that are old. These are two guys that are old. These, Using the last blocking assignment, describe in detail how you would assign treatments to the subjects. So I would use a fair coin. So I would take the two numbers from each block and flip a coin. Flip the coin. If the coin comes up heads, I will give the new formula to the low number subject, and the old to the larger number. If coin lands tails, I will reverse it. I will give new to the larger number and old to the lower number. This is one way to do it. Somehow you need to randomly assign the old and the new shampoos to the two people in the group. This is one example. You could do any number, any other things you want. You could write 4 and 5 on a slip of paper and mix it up, put it in a hat, mix it up. Whichever number you draw out first gets the new, the other gets the old. And you could do that, repeat that process for all the groups. Repeat for each block. These are common types of questions that you see on the AP test. And kids a lot of times lose points on it because they don't want to sit there and, you should be able to just say randomly assign the subjects to the two shampoos. But to get credit for this, you need to have the detail, okay? Oh, by the way, we could try another form of blocking where this is maybe the most powerful form of blocking, where each person will at different times test the new shampoo and the old shampoo on their hair. Nobody is more like volunteer number 1 than volunteer number 1. So why not try the new shampoo and the old shampoo and see how they compare on that person's hair? And do that for every single one of the individuals in the experiment. That's a form of blocking that's a matched pairs design that's maybe even more powerful than the setups that we had here. Okay? The randomization would just happen as whether you test the old shampoo first or the new shampoo first. Okay? Because if you always do the old first and the new second, maybe the combination of doing old first and then the new second somehow makes the second application much better than the first. But if you randomly assign it and sometimes do the old first and then the new, you should be all right. So, all right. Got a nice long example. I don't want to do another video, but I don't think I can do this example in 5 minutes. Let's go to the next video.